Hello, my name is Caitlin and I'm a PhD candidate researching the concentration of stabilized human urine using reverse osmosis to produce liquid fertilizers. Urine contains all the key components of fertilizer, but is 97% water and so expensive and logistically challenging to transport. Our proposed concentration and nutrient recovery method is reverse osmosis, as this is a well-established technology and accounts for 44% of global seawater desalination. A comment we often receive is that RO is expensive, and if water is your product, then yes, it is. Bulk water can only be sold for approximately R4 per cubic meter, and the brine still requires disposal. In our process, the brine is the product. Chipako et al. Determined that niche liquid fertilizers can be sold for at least R155 per liter, with water being an additional useful byproduct. Calcium hydroxide is added to urine to prevent urea breaking down and therefore maximize nitrogen recovery. But this leaves us with urine that is saturated with calcium hydroxide, which then forms solids during concentration and scales the RO membrane, looking something like this. We developed an air bubbling pretreatment process to remove the scaling precursor ion calcium. The calcium reacts with carbon dioxide in the air to form calcium carbonate, which can then be filtered out before reverse osmosis, thus preventing scaling. We also looked at using an acid to prevent urea breakdown, but this resulted in the formation of crystals, which we found out to be uric acid dihydrate or kidney stones. This ultimately resulted in membrane scaling, thus making acid stabilization unsuitable for an RO process. Urine pre-treated with air bubbling showed a significant improvement in flux, and the membrane no longer became scaled. We also saw an improvement in urea rejection. Untreated urine has a pH of 12.5 compared to 8.5 for air-bubbled urine. The pH range for most commercial membranes is between 12 and 11, so the reduction in urine pH also appeared to improve urea rejection. So what does this mean? Overall, we were able to recover 85.5% of the urea whilst reducing the stream volume by 60%. Different treatment options work at different scales. This process would not be feasible on a household level, and instead you might use evaporation. We envision this process being implemented where urine can be collected on a large scale, such as in airports, shopping centers, or festivals. The urine would then be concentrated on an on-site treatment facility, the fertilizer product sold, and the water recycled within the building for non-potable uses. One step closer to closing the loop on resource recovery.